We're given a special whole life insurance on age X. The death benefit is 1,000 for the first 10 years and 2,500 thereafter. Death benefits are payable at the moment of death. Okay, and we're given Z as a present value. The force of mortality is 0.01 when t is less than 10, 0.02 when t is greater than or equal to 10. And then delta t is 0.06 and 0.04. So we want to calculate the probability that Z is greater than 700. This problem is tricky because it's not a nice straightforward answer. Usually, we're given something like this with one force of mortality and one delta. But here we're given two separate ones. So the graph is going to look a little different. You're going to have two separate graphs. So one graph is going to be less than when t is less than 10. The other graph will be when t is greater than or equal to 10. So you want to consider both cases. So we want to see when the probability z is greater than 700. First, let's look at it in the first graph. So when t is less than 10, let's see if that happens even. So let's say a person dies and the present value will be 1000 e to the negative 0.06 t. You want that to be greater than 700. So you have e to the negative 0.06 t greater than 0.7. So then you would just take the log and get that t is less than 5.94458. Always check that this is part of the interval. We were looking at t is less than 10, and yeah, we found a number less than 10. Okay, so that's the first time it happens. Now this is the probability that someone will die before 5.94458. Okay, so that we started at what age X actually, so they didn't specify an age. But we don't care what age it is because the force of mortality is constant. So that's 1 minus e to the negative 0.01 times 5.94458. And we calculate this to be 0.057713. So that's one of the answers that we need. So that was for the interval where t was less than 10. Now let's look at the interval between t is greater than or equal to 10. Okay, so if the person dies after time 10, you have to discount it twice. Like you want to use a discount from 0 to 10, you want to use a discount 0.06 and then 0.04 afterwards. So maybe if we could draw a little time diagram. So this will just represent t. Okay, so let's say if a person dies here, then you have to discount it back here. What is it? That was 0.04. And then you want to discount it back when delta is 0.06. So the person will get a payout of, actually 2,500. Now that the death benefit changes. 2,500. So we would discount it. Let's see. Let's say this will be like 10 plus t, whatever, will be the age of death. So that means t years with 0.04 as the interest rate. And then we need to discount it back another 10 years. So that would just be negative 0.06 times 10. And you want this to be greater than 700. And I also should add that it should really be t minus 10 because we're looking the probability in this range. We're not going to be counting this probability here. This probability was factored to get to this answer. But we're looking at the probability that it's after time 10. So that's very important to get the question correct. Okay, so doing some algebra, we end up getting t is less than 26.82414. So that's quite a bit out here. Because we're in the interval between 10 and above, the difference there is the same thing as dying within 16.82414 years. So that's the same thing as so there's a couple ways to think about this. Let me redraw it. Okay, so we're looking at this probability right here. So you can think of it as like, okay, 10 starting age, I guess x plus 10, because person is age x at time 0, and you're surviving 16.82414, which you can also represent it as surviving, so times 0, 26.82414, and then subtracting it, or sorry, the other way around. So surviving 10 years and then subtracting it, surviving 26.8244 years. So yeah, that should give you the same answer. And when you do all of this, you end up getting 0.25853. Okay, so again, actually here, you do want to use, I guess we should talk about it briefly, force of mortality, and let's see, so force of mortality here was 0.01, okay, minus, and then here there was two different force of mortality, so 0.01 for 10 years, and then afterwards it was 0.02 starting at year 10, so that would, we have to subtract 10. So there's two different probabilities that we have. So 0.057713, 0.25853. So we have to add those up. And get the final answer is 0.31624.